Student, next one about interhalogen compounds are CLF. CLF, you can say, read it CLF, that is chlorine fluoride. Student, I am drawing 3-4 structures here. On the basis of it, you can draw the structure of all compounds. Okay, so how to draw the structure of interhalogen compound? So for that we have to select very first the center atom. The center atom must be bigger in size with lesser electropositivity. So this will be what? Cl. Its outermost electron is 7 and the configuration is NS2 and NPX2, NPY2 and NPZ1. Now there is NPZ1 configuration, that is the unpaired electron present in Z orbital. F, the number of F is only 1 and this is what? Monovalent. That is what? Only one covalent bond required. Thus, the hybridization state is including up to one unpaired electron and the hybridization state will be what? sp3. Now student, you know that the sp3 is always what? Tetrahedral. But if the lone pair is present, then the structure is little getting changed. Now how it will getting changed? So write here what? Cl. In hybridization 4 orbitals are there, 1, 2, 3, 4. But the 3 containing a paired orbital, so the paired orbital can be denoted by what? Lone pairs. So there will be 3 lone pairs and 1 is what? Unpaired. So it is denoted by like that. So with the unpaired, it forms covalent bond with Cl while the 3 remains in the form of lone pair. Thus, overall, the structure is given on the basis of FCLF. Therefore, the structure is linear. Structure is linear. So this is one of the compound. The second compound, if we consider BrF3, okay, trifluoride, bromine trifluoride. Now the center atom is what? Br again. The hybridization state is NH2 and again similar what? NPX2, NPY2 and NPZ1. But how many number of F is there? 3 numbers of F are there, that is fluorine atoms are there. That means what? Being it is monovalent, require 3 unpaired orbital. Thus, there is what? Vacant d subshell. One of the electron from NPY2 gets jumped to d subshell. Thus, now the configuration becomes what? NS2, then NPX2, NPY1, NPZ1, and now in D there is one again unpaired orbital. Now these 3 unpaired orbital will hybridize forming sp3d1 configuration. Getting? Now in sp3d1 configuration, you know it is trigonal bipyramidal. That is the simple structure. But what will be the actual structure? The trigonal bipyramidal will be if all the orbitals are unpaired. But here remember 2 orbitals are paired. That means it will not follow trigonal bipyramidal structure, but there will be little change in the structure. How it is little change? So you do write what? Br. This is the center atom. Now 2 lone pairs are there. So this is one of the lone pair. This is second lone pair. There will be great repulsion between the lone pairs. Thus, the 3 bond pair are little what? Repel. So here 1F, second F and third F. This is called bent T-shaped. Bent T-shaped structure. Bent T means if we write in this form, it become a permanent T. But little bend is there, therefore called bent T-shaped. Okay. So can we draw for BrF5? BrF5. So again write Br what? The ground state configuration is NS2. I am calling it NS2. Okay. This is NPX2, NPY2 and NPZ1. But still there are what? 5 number of D. vacant orbitals are there, being it is what? Pr. Thus, now total surrounding atoms are 5 in number, which are monovalent, so it requires 5 vacant orbital. Thus, one electron from X and one more electron from Y is getting jumped. That means now the excited state configuration becomes NS2. This is NP X1, NP Y1, NP Z1, and now the D subshell has 2 excited electron D1 and D2. Thus the overall configuration, it becomes what? sp3 D2. And you know that sp3 D2, it belongs which one? Octahedral. Octahedral. Now what about octahedral? The Br will be in center. But remember student, there will be what? One paired orbital. This one is paired orbital. That is, it will form lone pair, and the 5 will form bond pair because 5 F atom is there. That means now this is one of the B, second B, third B, fourth B. This one is fifth B, which will be little bigger in size, while this is what? Lone pair. And we can draw the structure in this way. This is the structure of BrF5. Are you getting? In the similar manner, you can form for IF7 or for ClF3. Only you have to change the center atom. Rest of the thing will remain same. Student, about the properties of interhalogen compound. So the reactivity of this compound is little different as compared to the simple halogen compound, like reactivity. So being polar in nature, interhalogen compounds are more reactive than simple halogen molecules. Now what about simple halogen molecule? Simple halogen molecule, that is what? XX, or you can write F2, or we can call what? ClF. Like if there is a compound F and F, so it is completely non-polar. Being non-polar require more energy for bond dissociation. While if we call about interhalogen compound, now there is ClF, and the ClF, being F is more electronegative, so it acquires fraction negative charge, and the chlorine acquires fraction positive charge. That means now, being it is polar in nature,